Hello and welcome to Mass Academy. In today's class, we are discussing Physics Term 1 Examination December 2022, Grade 9 Advanced in Spare. So there are three chapters for Term 1, three units. Unit 1, Unit 1 Physics Toolkit, Physics Toolkit, and the name of Unit 2 Representing Motion. And Unit 3 Accelerated Motion. So you have to study three units: Physics Toolkit, Representing Motion and Accelerated Motion in Term 1 or for Term 1 examination. And in this exam, that is in the Term 1 exam of December 22, there were 6 questions from Unit 1, from Physics Toolkit, 6 questions, and from Unit 2, Representing Motion, 6 questions out of 25 questions, right? Total 25 questions, 20 questions and 5 bonus questions for 120 marks. Each question has 5 marks and each bonus question has 4 marks. So total marks will be 120. And how many questions remaining out of 25? 6 plus 6, 12. So 13 questions remaining. And these 13 questions from Unit 3, that is Accelerated Motion, means you need to give more focus on accelerated motion to score a good mark. Now we will discuss each questions in chapter wise. First we will discuss the 6 questions from Unit 1, then the next six questions from Unit 2, then the questions from Unit 3, that is Accelerated Motion. So we are going to discuss each questions in the examination in the order of the unit. So first question number 1. This question is from the significant figures, okay, from the topic significant figures. They have given a number. What is the number of significant figures in the given number? This is the question, what is the number of significant figures in the number 0.0004020. So this is the question, and they have given the choices 2, 7, 4, 8. So these are the choices given, the answers given in the question. So what is the correct answer? What is the number of significant figures in the given number? To know the number of significant figures in a given number, there are 3 rules. So for example, I will discuss, okay, because in the next examination they will give questions from significant figures, but they will change the number. So we will discuss how to find the number of significant figures if they give any number. So number one, if the given number is a decimal number that is equal to 1, for example 1.00, so this is a decimal number that is equal to 1, or another number like 1.0100, this number is decimal number that is greater than 1. Decimal means this point, this dot is called decimal. The number with that dot is called decimal number. So what is decimal number? Number with this dot. So this number is greater than 1. So if I write another number 1.530, this is a decimal number that is greater than 1. If I write 2.00 or 5.0205, all these numbers are decimal number that is greater than 1. So rule number 1, if a decimal number is given that is equal to 1 or greater than 1, then all digits in that number are significant. So all digits in these given numbers are significant. How many digits here? 1, 2, 3, 3 digits. So number of significant figures 3. Here how many digits? 1, 2, 3, 4, 5. So number of significant figures 5. Here how many digits? 1, 2, 3, 4. Number of significant figures 4. Number of significant figures 3. Number of significant figures 5. If the given number is a decimal number that is equal to 1 or greater than 1, if a given number you can write, okay, that's why I am writing the rule here. If a given number is equal to 1 or greater than 1, equal to 1 or not 7, okay, it is 1, okay, equal to 1 or greater than 1, then all digits in that number are significant. So this is the first rule, rule number 1. If a given number is equal to 1 or greater than 1, if a given number is a decimal number, okay, if a given number is a decimal number, okay, if a given number is a decimal number that is equal to 1 or greater than 1, then all digits in that number are significant. That is rule number 1. So I have given these examples. All digits are significant in these given numbers. Why? Because they are either equal to 1 or greater than 1. Then I will write our rule number 2. Rule number 2. If a given number is a decimal number but that is less than 1, not equal to 1, not greater than 1, that is less than 1. So if a given number is a decimal number, if a given number is a decimal number decimal number less than 1, decimal number less than 1, then what happened? Then starting zeros are not significant. All other digits are significant. What is the rule? If a given number is a decimal number that is less than 1, then starting zeros are not significant. All other digits are significant. For example, we will take this number in this question, this is a decimal number because there is decimal here, and the value of this number is less than 1. What is that number? 0.0004020. If a decimal number is less than 1, then starting zeros are not significant. If a given number is a decimal number less than 1, starting zeros are not significant. So these 3 zeros are not counted as significant digits. All other digits are significant. Only starting zeros you don't have to count. Remove the starting zeros. All other digits are significant. Starting zeros means zeros before a non-zero digit. Here the first non-zero digit is 4. So zeros before first non-zero digit are called starting zeros. The starting zeros are not significant. All other digits are significant. So how many significant digits here? 1, 2, 3, 4. So we have significant number of significant figures 4. So what is our answer? The answer to this question is 4. Then we will discuss the rule number 3 also. Why are we discussing rule number 3? Because in the next examination also they will give question from significant figures, but they may not give the same number. They will be giving a different number. So if they give a different number, you must be able to write the correct answer. So rule 3. Now we have done with this question, right? So we can remove these things, no problem, right? Okay, so we have removed that. And rule number 3, if a given number is a whole number. So we have 3 types of number in significant figures. What is the first one? First one is a decimal number, that is equal to 1 or greater than 1. Decimal number equal to 1 or greater than 1, that is the first type of number. Second type of number, decimal number less than 1. Third type of number, a whole number. If a given number is a whole number, then what is the rule? The ending zeros are not significant. All other digits are significant, including zeros. Okay, only ending zeros are not significant. All other digits are significant. For example, if I give you 5,000 or 50,500, 3,280, 30021, 420,100. So I have given 4 whole numbers. What's the meaning of whole numbers? Number without this decimal, okay, without the decimal point, that is called whole number. Here you cannot see any decimal here, so these are whole numbers. In a whole number, if the given number is a whole number, ending zeros are not significant. Ending zeros are not significant. Ending zeros are not significant. All other digits are significant. So here how many significant figures? 1, 2, 3, 3. 1, 2, 3, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4. So this is all about significant figures, how to count number of significant figure in a given number. If you understand these 3 rules, you will be able to answer any question given from significant figures. So there are 3 types of number in a significant figure question, they will give three types of number. The first type is a decimal number that is equal to 1 or greater than 1. Second type is a decimal number that is less than 1. Third type is a whole number. Question 2. Which formula is equivalent to the kinetic energy equation? Which of the following formula, okay, which formula is equivalent? Equivalent means same. Which formula is same as the kinetic energy equation? Equivalent to kinetic energy. Kinetic energy. What is kinetic energy? Energy of a moving object, or energy due to the motion of the object, energy possessed by motion of the object. Kinetic energy equation. So which formula is equivalent to kinetic energy equation? Kinetic energy equation E equal to half mv squared. That equation is given, and you have given four choices. Okay, four choices. First one is m is equal to 2e v squared. Then m is equal to 2e divided by v squared. Second choice. Number third, m that is equal to, m means mass, okay, v squared divided by 2 multiplied kinetic energy. And the last one, m is equal to half e v squared. So these are the four answers given. Out of these four answers, which one is same as this equation? Same as this equation of kinetic energy, the given equation of kinetic energy. So how to solve it? The best idea is rewrite the equation, rewrite all the given equation for kinetic energy. So if you get same, then that will be the answer. For example, this one we will write for E. So kinetic energy, I am just rewriting the first one. Kinetic energy, that is equal to m divided by 2v square. So this is not correct, right? Why not correct? M numerator, that is correct, divided by 2, okay, but v here, v that is in the numerator in the given equation, but here it is in the denominator, means divided by v square, that is not correct. So I will check this one. Second one, E that is equal to m into v squared we will take to the other side, divided by 2 will come here, right, divided by 2. So it is same, see, E is equal to half mv squared, here also E equal to mv squared divided by 2, same, right? So this is the correct answer. If you rewrite this two equation also, you will not be getting same as the given equation of kinetic energy. So this equation is the answer. This equation, m is equal to 2ev squared, this one is equivalent to this, means this one and this one are same equation. Okay, to reduce the length of the video, I am not discussing the other 2, 3 and 4 choices, so that you can check whether when you rewrite for kinetic energy, are you getting the same equation for kinetic energy or not. Question number 3. Mariam used a cylinder to measure volume of an unknown liquid. The volume she measured was 46.0 milliliter. 46.0 milliliter. Here all the answers are given in liters, which means you need to convert that milliliter into liter. Then she asked the teacher asked her to mix it with 1.20 liter of water. What is the volume of the mixture? So here we have the mixture, we have the chemical that is in 46 ml, right? 46 ml, 46.0 milliliter. M stands for milli. What is the power of 10 of milli? 46.0 milli means 10 to the power negative 3, right? Okay, so here when you calculate this, you will get 0.046 liter. When you convert milliliter to liter, to convert milliliter to liter, you need to divide by 1000, right? So 46.0 divided by 1000, that will be equal to 0.046. Then she added that much volume of the liquid into water, or 1.20 liter of water. So 1.20 plus 0.046. So what's the answer? 6421 point. So 1.246 liter, right? So here we have 3 decimal place, and here we have only 2 decimal place and 3 decimal place. So when you write the answer should be written in the least number of decimal places. That here the answer is obviously clear, this will be the answer. But why we should not write 246? Because we need to write the answer in least number of decimal places. So here number of decimal places are 2. So we will round the answer into 1.25 liter. So here what is the point in this question? The point is you need to convert this milliliter to liter. How to convert? By dividing by 1000. This question number 4 from the topic measurements. So in this question, below there is a data produced by 4 groups of students who were measuring the mass of a paper clip. Its actual mass, the real mass of the paper clip is 1.04 gram. Which group got an accurate and precise measurement? Accurate and precise measurement. We will discuss each question in a way that by understanding this question, you should understand the topic. So we will discuss the question in detail. We will discuss what's the meaning of accurate, what's the meaning of precise, and which one is accurate and precise. Accurate means your measurement, how close your measurement is to the true value, the actual value. Accurate means how close your measurement to the true value. If it is very close to true value, your measurement is more accurate. If your measurement is away from the true value, your measurement is not accurate. Precise means when you are repeating the experiment, you are measuring 3 times, 4 times, 5 times, and you are getting the same reading or almost the same reading again and again, then we say your measurement is precise measurement. Precise means how close your measurements to each other. When you repeat, how close are you getting each values? That is called precise measurement. Here if we check the group 1, 1.03, that is very close to 1.04. Means 1.03 is very close to the correct reading, the actual value, the correct mass of the paper clip. 1.05, 1.02, all these measurements are very close to the true value. So these measurements are accurate, and all these measurements are very close to each other, very near to each other. So these measurements are both accurate. These are accurate and precise. Why accurate? Because these measurements are very close to the correct value. Why precise? Because these measurements are very close to each other. So group 1, this is our answer for this question. Then what about this one? You can see the actual reading is 1.04, but here 1.13, 1.10, 1.11. These are not accurate. These are not accurate, because this is not close to the true value, but these measurements are very close to each other. When you repeat, you are almost getting the same answer. So these measurements are not accurate but precise. When you repeat, you are getting the same answer again and again, which means the problem is with the machine, with the instrument. It's called systematic error. So this mistake is due to systematic error. So here you can see 1.04, 1.41, 1.52. These are not close to the correct value and they are not close to each other. So not accurate, not accurate, not precise. And here also, this also, okay, this is not accurate, right? Not accurate, because 1.19, 1.00, 0.99. So this is not close to the true value. This is not close to the true value. So this also not accurate and not precise. So the answer for this question is group 1. Group 1 reading are accurate and precise. Now we are discussing question number 5. Equation is f is equal to mv squared divided by r. So there are two variables f and v. So according to this equation, what is the relationship between these variables f and v? So here, according to this equation, you can see f is directly proportional to v squared. If a variable is directly proportional to the square of the other, this type of relationship is called quadratic relationship. Quadratic relationship. And we have two more other relationships, that is linear relationship and inverse relationship. If f is proportional to v, then this is called linear relationship, linear. And if f is proportional to 1 by v, this is called inverse relationship. Inverse relationship. So answer to this question is this one, quadratic relationship. The relationship between f and v, the variables f and v, is quadratic relationship. Why? Because f is proportional to the v squared, square of the other variable. So if we draw a graph of f against v square, f against v, the graph will be like this. It will be a curve, and in linear relationship the graph will be linear, means a straight line. And in the inverse relationship, if we draw the f against v graph for inverse relationship, the graph will be like this. So in this question, what is the relationship between the variable f and v? It is a quadratic relationship. Why quadratic? Because f is proportional to square of v. In question number 6, a worker in steel factory needs to write down the temperature of a steel rods using the SI unit. Which of the following unit he should use? So what is the SI unit of temperature? The worker in steel factory, he is measuring the temperature. What is the SI unit of temperature? Here 1, 2, 3, 4 choices given, like Fahrenheit, Kelvin, Celsius. So in that, what is the SI unit of temperature? The SI unit of temperature is Kelvin. Kelvin is the SI unit of temperature. SI unit for temperature is Kelvin. Okay, SI unit of temperature is Kelvin. That is the SI unit of temperature. Now we have discussed all 6 questions from unit 1, that is physics toolkit. Now we are discussing question number 7. And next, including this question, the next 6 questions from chapter 2, that is representing motion. A truck is at a position of 125 meter away from the origin. So origin is here, and now the truck is 125 meter away from the origin to the right side and moves towards the origin. The truck is moving towards the origin. So it's like truck is moving back to the origin, moving to the left side. Displacement to the left side we consider negative. What is the velocity of the truck in a given time? What is the equation to calculate velocity? Velocity, that is equal to displacement divided by time taken, that is delta x divided by delta t, that is called the velocity v. Displacement divided by time taken. So what is the meaning of displacement? Displacement is final position minus initial position. After 5 seconds the truck is reaching the origin, so final position is 0 minus what is the initial position? Initial position is the position when it is started, right? So that is 125 meter divided by time taken. Final time minus initial time, that is the time taken. When it reach the origin, when it reach its destination, the time is 5 seconds, so that is the final time, 5 seconds, minus when it is started, the time is 0. The time is given here, okay? In the question also time is given. In the diagram the truck is here. So the initial time is 0. So it will be negative 125 divided by 5. That is equal to negative 25 meter per second. Meter per second is the unit of velocity. So negative 25 meter per second is the answer to question number 7. Question number 8, to calculate the distance and displacement. Adam started moving from point A. He passed point B, C, D as shown in the figure. What is the displacement and distance respectively? So here Adam is here at A, and first he is going to B, then he is going to C, then going to D, then returning to position A. So Adam is moving along this path from A to B, B to C, and C to D, then back to A. So here A to B the distance is 3 meters, and B to C the distance is 5 meters, C to D the distance is 3 meters again, and this will be 5 meter. So we need to write the displacement and distance respectively. Displacement and distance, right? Displacement and distance respectively means in that same order. So what is the displacement? So Adam started from here. This is the starting point or the initial position, right? Starting point, and Adam is reaching the same point. So final position, initial position and final position same, right? Starting, instead of starting I will write initial. So initial position and final position same, because we reached the same place. What is displacement? Displacement is the shortest distance from initial position to the final position, or final position minus initial position. So here final position and initial position same, so displacement will be 0. So if you travel and return to same place, you are traveling like 10 kilometers in a circle, your displacement will be 0 if you reach, when you reach your starting point. And what is the distance traveled? What is the meaning of distance travel? Distance means the total length of the path he traveled. The total length of the path he traveled. For example, I am walking here, right? When I am recording this video, I am walking here and there, to the front, to the back, to the board, to my phone. Like that I am walking. But if we calculate the displacement, it may be 0, or it must be 0, because I am always here, right? At the same position. But if we calculate the distance traveled, if I calculate the distance traveled, like in 1 hour video, I may be walking like 1 kilometer, maybe walking 1 kilometer. So in this case, how much is the total length of the path he traveled? 3 plus 5 plus 3 plus 5. What is 3 plus 5? 8. 3 plus 5, 8. 8 plus 8, 16. So 16 meter is the distance traveled. Okay. 3 plus 5, 8. 8 plus 3, 11. 11 plus 5, 16. So displacement is 0 and the distance is 16. So this is the correct answer. So here, like 4 different answers given: 0 and 34, 16 and 16, 34 and 34, 0 and 16. So 0 and 16 meter is the correct answer. Now we are discussing question number 9. I am not writing the question completely as it takes more time. So I will read the question. The position time graph below shows a cyclist's location in a 60 time interval. So up to 60 second time interval, the graph shows the position of a cyclist. What is the cyclist displacement from the starting after 40 second? From starting to the 40 second, what is the cyclist displacement from the starting? Starting is here, right? When time is 0, that is called a starting point. So when time is 0, the cyclist position is here at 250 meters. He is already at 250 meter away from the origin when we are starting the observation. So after 40 second, what is the cyclist position? In the graph it is clearly given. After 40 second, the position of the cyclist is 450. So you need to calculate what is the cyclist displacement. Displacement that we represent by delta x, change in position. Delta means change, x represent the position, change in position, that is called displacement. Delta change, x position, change in position. What is change in position? Final displacement, final position minus initial position, that is called displacement. Final position minus initial position. What is final position? Means after 40 second, what is the position of the cyclist? After 40 second, the position of the cyclist is here, 450. So 450 meter minus initial position. What is the initial position? When time is 0, what is the position of the cyclist? Position of the cyclist is 250 meter. So 450 minus 250, that is equal to 200 meter. 200 meter is the correct answer to this question. So 4 choices given. In that there is 250 meter, 400 meter, 450 meter and 200 meter. So the correct one is 200 meter is the displacement. How to calculate a displacement? Displacement is delta x. Delta means change, x means position. So change in position. Change in anything, that is final minus initial. What is like change in the age, final age minus initial age. Change in mass, final mass minus initial mass. Change in position, final position minus initial position. So final position is the position after 40 second. Why after 40 second? Because in the question it is given what is the displacement from 0 to 40. So 40 is the final time. So final position is 450. From 40 go to the graph, then from the graph go to the position axis. Okay, 450 minus 250, that is equal to 200. Question number 10 is from position time graph. Position on y-axis and time on the x-axis. Position we represent by the letter x, time we represent by the letter t. So this graph reads position time graph. Whenever we name a graph, we read the y-axis first, then the x-axis. So this is position time graph. So here the question is, in figure below shows a simplified graph of bicycle's motion. When is bicycle's speed greatest? Greatest speed. So speed, what is the relation between speed and position time graph? Speed and position time graph. The slope of position time graph, that is equal to speed of the object. Slope of position time graph is equal to speed of the object. So which part, which section of the graph has the greatest slope? That section, the object has greatest speed in that section. So here is section 1, section 2, section 3. Here you can see section 3, that is steeper, right? Steeper. So it has the greatest slope. The slope is greatest in section 3, that you can see how much it is slanted. So here the slope is less, right? Here the slope is more, the gradient, okay? Slope is also called gradient. So the maximum gradient is in section 3. The greatest speed where? In section 3. So section 3 is the correct answer. Now we are discussing question number 11. So this is a position time graph. On the y-axis position, on the x-axis time. So the question is that the graph below represents position time for a deer walking in zoo. Which time is the deer's? Which time is the deer at rest? So here you can see between 3 and 4 the position is here, right? Position is, it is given like a 5 here. So 1, 2, 3, 4, 5. So at the 5 meter, right, between 3 and 4 the deer is here at 5 meter. At 5 meter. So it is not changing its position from 3 to 4, right, between 3 second and 4 second. Between 3 second and 4 second, or we can say 3 to 4 second, the deer is at rest. So the answer is 3 to 4 second. 3 to 4 seconds, the deer is at rest. So what are the choices given? It is given 3 to 4 seconds, 0 to 2 seconds. What is in 0 to 2 seconds? 0 to 2 seconds, it is moving, okay? It is moving at a constant speed, moving with a positive velocity, we can say. Positive constant velocity. And 3 to 6, not correct. 3 to 4 is correct, okay? In 3 to 4 you can see here the graph is horizontal line. Okay, so that represent the deer is not moving. So if in like, what about 3.5? At 3.5 also it is at rest, right? Because in between 3 and 4 the deer is at rest. Question number 12. So this is the last question from chapter 2, representing motion. This question also from position time graph. The position time graph for 4 different objects are shown below. If the positive direction is forward, then which object is moving backward at a constant velocity? So this one is not correct because this is a curve, right? And so velocity is not constant. Then here this is also not correct. Why? Because in this the object is not moving, object is stationary. So the question is, which object is moving backward at a constant velocity, moving back? So here you can see this one is, first it is moving from left side, moving towards the origin. So it reached origin here. Then it is moving away from the origin. So which means this also, in this the object is moving forward. It is moving to the positive direction, right? So which one is moving backward? Here you can see when time is 0, this is initially a distance away from the origin to the right side. Why to the right side? How to know? Because here you can see this is positive, right? So the object is away from the origin to the right side at the beginning. and what is happening, the object is moving towards the origin. How to know towards the origin? You can see when time is increasing, the distance to the object or distance to the object from the origin is decreasing, which means the object is moving towards the origin, which means the object is moving back. So how to know it is moving at a constant velocity? Because position time graph is a straight line. If position time graph is a straight line, then it means the object is moving at a constant velocity and it is moving towards the origin. So we can say the object is moving backward towards the origin at a constant velocity. So this graph is the answer for question number 12. The next question is, from accelerated motion, a car slows down in a constant rate of 10 meter per second squared. So here 10 meter per second squared, you can see here meter per second squared. Meter per second squared is the unit of acceleration. So here the value of acceleration is 10 meter per second squared. Here you can see a car slows down in a constant rate of 10 meter per second squared. There is no word acceleration in the question. So how to know the value of acceleration? What's the value of acceleration given in this question? How to know that? You can know from the unit. So just to see with this number, what is the unit given? Here unit is meter per second squared. Meter per second squared, unit of what? Unit of acceleration. So the value of acceleration in the question is 10 meter per second squared. That is how you come to know, or you need to analyze the question, what is given in the question, mainly from the units. If the car's velocity is 50 meter per second, here the word velocity is given. Here in this sentence the word acceleration is not given, so we understand the value of acceleration from the unit. Okay, here also meter per second is the unit of velocity, so 50 is the value of velocity. Okay, that is how we understand what is given in the question by reading a question. Okay, so here a car slows down in a constant rate of 10 meter per second. If the car's velocity is 50 meter per second, how many meters will it travel before it completely stops? And 4 choices given, and this is a question from accelerated motion, that is unit 3. And in accelerated motion, most of the numerical problems that you can solve using equations of motion. Equations of motion we have discussed before in our video of equations of motion. So I will write these equations of motion. We have 3 equations for motion. Number 1 is first equation, that is final velocity equal to initial velocity vi plus acceleration multiplied time. Velocity final, that is equal to velocity initial plus acceleration multiplied time. That is the first equation, equation number 1. Then second equation, equation number 2, displacement we represent by delta x, displacement that is equal to velocity initial into t plus half multiplied acceleration multiplied time squared. Third equation, velocity final squared, that is equal to velocity initial squared plus 2 multiplied acceleration times displacement. These are the 3 equations, equation number 1, equation number 2 and equation number 3. So there are 3 equations. So how to know which equation you need to use in a given question? That is a confusion, right? Because there are 3 equations and 1 question. So out of these 3 equations, which equation will you use in this question? There is a technique to understand that. So what you need to do is, first you need to know when to use the first equation. So in every accelerated motion questions, you have 5 data. What are the 5 data? You have 5 things here, that is velocity initial, velocity final, acceleration, displacement and time. These are the 5 data. So here in this question, a car slows down in a constant rate of 10 meter per second squared. So 10 meter per second squared, that is acceleration, it is slowing down. So the value of acceleration is negative. Why negative? Because here in the question it is given, see, car slows down. That is why the value of acceleration is negative, 10.0 meter per second squared. That is the value of acceleration given in the question. If the car's velocity is 50 meter per second, so velocity initial of the car 50 meter per second, how many meter will it travel before it completely stops? When it completely stops, its velocity is 0. So velocity final is 0. And what do you need to calculate? How many meters will it travel? You need to calculate the displacement traveled. So what about the time? Out of this 5 data, there is no information in this question about time. Time is not given and you don't have to calculate time. So time not given. If time not given, you can see in this equation, time not given, right? There is no time. So if time not given, you will use this third equation. Then what about the second equation? Check in the second equation, out of this 5, which one is missing in this? Delta x is there, initial velocity, time, acceleration, time is there. So what is missing? Final velocity is missing. So you will use the second equation if Vf not given, means if final velocity not given. In a question you will use that equation. When will you use the first equation? Final velocity, initial velocity, acceleration, time. What is missing? Displacement, delta x. So if displacement not given, you will use the first equation. So in this question, time is not given. So which equation are you going to use? You will be using the equation number. You will be using the equation number 3. So equation number 3 is final velocity squared, that is equal to initial velocity squared plus 2 multiplied acceleration into delta x. What is the value of the final velocity? Final velocity is 0, 0 squared is 0. Initial velocity 50, so 50 squared plus 2 multiplied acceleration, value of acceleration is negative 10 multiplied delta x. That is equal to 50 squared 2 into 10, 2 multiplied negative 10, so it will be negative 20 delta x. Now we need to calculate delta x, means displacement is what we need to calculate in this question. So delta x, negative 20 delta x I will take to this side, so it become 20 delta x, means 20 times delta x, that is 50 squared. So displacement, that is delta x equal to 50 squared divided by 20. When you calculate this, you will get 125 meters. So out of this 4 answers given, means 4 choices given, 125 meter is the correct answer for this question. This is the next question from accelerated motion. A car starts from rest and goes down a hill with a constant acceleration of 5 meter per second. So whenever we solve numerical problems from equation of motion, from accelerated motion unit, first you need to write the 5 data. What are the 5 data? Velocity initial, velocity final, acceleration, displacement, time. So when you read the question, you need to write these 5. Then you need to check what is not given in the question. According to that, you need to select one equation from here, apply, substitute values, find the answer. So a car starts from rest. If anything starts from rest, its velocity initial will be 0. So velocity initial, that is equal to 0. Vf, velocity final. V for velocity, F for final, and goes down a hill with a constant acceleration of 5 meter per second squared. Here acceleration is 5 meter per second squared. It is starting from rest and moving, which means the speed is increasing, right? So here acceleration is positive. After 5 seconds, the car reaches the bottom of the hill. So time is also given, that is 5 seconds. After 5 seconds, the car reaches bottom of the hill. What's the car's final speed? We need to calculate the final velocity. And what about the displacement? Displacement not given in the question. If displacement is not given, choose the equation in that displacement is not there. So equation number 1, delta x not given. So you will be using the first equation, equation number 1. So final velocity, that is equal to initial velocity plus acceleration multiplied time. You need to calculate final velocity. Initial velocity 0 plus acceleration 5, and time, the value of time is also 5. So final velocity, that is equal to 25 meter per second. 25 meter per second is the value of final velocity. And what are the choices given in this question? In this question, 4 choices given, that is first one 50 meter per second, another one is 25 meter per second, another one is 1 meter per second, the last one is 10 meter per second. So what's the answer? Our answer is 25 meter per second. That is the correct answer for this question. In the next question, a stone is thrown upwards with initial velocity of 20 meter per second. What is the maximum height the stone will reach? A stone is thrown upwards like this. A stone is thrown upwards. So what is the maximum height reached by the stone? So here this is from accelerated motion and from free fall. What's the difference in free fall? What's speciality in free fall? In free fall, the value of acceleration will be equal to 9.8 meter per second squared. Everything else is same. We can solve free fall question using the equation of motion, means using the equation of motion from accelerated motion. Only thing that you need to do is, for this acceleration, all the value of acceleration you need to substitute 9.8. So 9.8 meter per second squared is the value of free fall acceleration. So a stone is thrown. So this is also from, this question is also from accelerated motion. So we will write the 5 data, right, what to do: initial velocity, velocity final, acceleration, displacement, time. So just to write this first, okay, when you know this equation. So this question is from accelerated motion or free fall, write these things first. A stone is thrown upward with initial velocity of 20 meter per second. Initial velocity is 20 meter per second. Positive. Why? Because it's thrown upward. What is the maximum height when the object reach maximum height? For example, when I throw this and it reach maximum height, at a maximum height, its velocity become momentarily 0. For a moment, for an instant, the velocity becomes 0 when it reach maximum height. After that, it falls down. So at maximum height, the velocity final, that is equal to 0. Acceleration will be negative 9.8 meter per second squared. Why? Because when an object is moving upwards, what happens? The velocity is decreasing, right? When object is moving upwards, its velocity is decreasing. That's why acceleration is negative. Displacement, you need to calculate. Time, what about time? Is there any information about time? Anything given? No, nothing, not given. Time not given, so we know which equation to use. Time not given, here take the equation. So final velocity squared, that is equal to initial velocity squared plus 2 multiplied acceleration multiplied delta x. What is final velocity? 0. 0 squared is 0. that is equal to initial velocity 20, 20 squared plus 2 multiplied negative 9.881 multiplied delta x. And we need to calculate delta x. So what happens, how to calculate, we will take this to this side, so it become delta x that is equal to 20 squared divided by 2 multiplied 9.8, that is equal to 20 squared divided by 2 multiplied 9.8, that is equal to 20.408. So 20.4 is the answer, 20.4 meter. 20.4 meter. So these are the 4 answers given in the question that I just wrote. What is given in the question? The 4 answers I wrote here. So what's the answer? 20.4 meter. The next question, that also from equations of motion. A car in a race started from rest. A car in a race started from rest and accelerated constantly to a velocity of 50 meter per second when it reached the end of 500 meter road. What was car's average acceleration? And 4 choices given for acceleration, that is negative 0.5 meter per second squared, negative 2.5 meter per second squared, 2.5 meter per second squared, and 0.5 meter per second squared. So these are the 4 choices given in with the question. A car in a race started from rest and accelerated to a velocity of 50 meter per second. So acceleration is positive, right, because velocity is increasing. Started from rest, started from 0 velocity, and velocity increased to 50. So here this cannot be correct, and this also cannot be correct, because those accelerations are given in negative values. Because here acceleration is positive, so you know that. Then without doing the calculation, you have 50% probability of getting the answer correct. So how to do the calculation? It's a question from equations of motion. Every equations of motion, you need to do the same thing. You need to do the same pattern, same method: initial velocity, velocity final, acceleration, displacement, and time. Write this. A car started from rest, right? Initial velocity 0, final velocity 50 meter per second. Why 50 meter per second? Because it is given in the question. Velocity increased to 50. When it reached a distance of 500 meter, when it traveled 500 meter, so displacement is 500 meter, acceleration you need to calculate, and time not given. Now you know, right, which equation to use. If time not given, which equation will you use? The third equation, right? Final velocity squared, that is equal to initial velocity squared plus 2 multiplied 2 times acceleration times displacement. So final velocity how much? 50. So 50 squared, that is equal to initial velocity how much? 0 squared plus 2 multiplied acceleration multiplied displacement is 500, right? So we need to calculate the acceleration. Acceleration, that is equal to 50 squared divided by 2 multiplied 500. So when you do this calculation, you will get 2.5 meter per second squared. So 2.5 meter per second squared is the answer to that question. Next question, also from equations of motion. A car travels a distance in 6 seconds if its initial velocity is 2 meter per second. And here we have 4 choices given in the 4 choices given as the answer: 14 meter, 48 meter, 24 meter and 12 meter. What's the answer? To know the answer, in every equations of motion question, velocity initial, velocity final, displacement, acceleration, time. A car travels in 6 seconds. In 6 seconds, so time is given 6 seconds. Acceleration given 2 meter per second squared. How far does the car travel? Distance you need to calculate. A car travel a distance in 6 seconds. Initial velocity also given. Initial velocity 2 meter per second. If its initial velocity is 2 meter per second, what is not given? Final velocity not given. You know which equation to use, right? If final velocity is not given, you will use the second equation because there is no final velocity in this equation. Second equation, if I write that here, displacement is equal to velocity initial into time plus half multiplied acceleration multiplied time squared. So displacement that you need to calculate, initial velocity to time is 6. So 2 multiplied 6 plus half multiplied acceleration 2 and time of 6 squared. So we will calculate it. We'll use the calculator. Hello. 2 times 6 plus 0.5 multiplied, why to 0.5? 1 by 2, okay? 2 multiplied 6 squared, that is equal to 48. So 48 meter. 48 meter is the answer. 48 meter. A coin is dropped from a building that is 25 meter high. The coin is initially at rest. How long does it take the coin to hit the ground? So a coin is dropped, free fall. So this question is from free fall. If anything is dropped, that is free fall. So a coin is dropped from a building that is 25 meter high. So even the question is from free fall, that is from equations of motion. So we will use the same method. Velocity initial, velocity final, acceleration, displacement, time. There is only one thing, right? One thing special for free fall. What is special for free fall? The acceleration is 9.8 meter per second squared. When you drop something, its velocity is increasing, right? When it is falling down, its speed is increasing. So acceleration is positive. A coin is dropped from a building. When you drop anything in any free fall, the initial velocity will be 0. When you are dropping, you are not giving an initial velocity. If you throw, you are giving an initial velocity. If you throw, it will have an initial velocity. If you drop, initial velocity will be 0. A coin is dropped from a building that is 25 meter height. The displacement is 25 meter. 25 meter is the displacement. How long does it take? How long? You need to calculate what? How long means you need to calculate time. Time you need to calculate. Final velocity not given. So you know which equation to use. If final velocity is not given, you will take an equation. In that equation, final velocity is not there. So in this equation, in the second equation, there is no final velocity. So we will take this equation. Displacement that is equal to initial velocity into time plus half multiplied acceleration multiplied time squared. Displacement is 25, that is equal to initial velocity, that is 0. 0 into time is 0. So half multiplied acceleration. The value of acceleration is 9.8 multiplied t squared. So t squared, that is equal to 2 multiplied 25 over 9.8. You want to calculate t. So t is equal to, you need to remove the square root. So we will take, you need to remove the square. So we will take square root on both sides, so it becomes 2 multiplied 25 divided by 9.8, that is equal to 2 multiplied 25 divided by 9.8 square root answer, that is equal to 2.25. so we will select this answer 2.3. we will select. What's our answer? 2.25 second, because we are calculating time. So when we round this answer into two significant figures, it is 2.3 seconds. In this question, this is a motion graph. What is on x-axis of this graph? On the x-axis, what is on y-axis of this graph? X, right? What does this x represent? X represent position. So this is a position time graph. Position time graph, it's a straight line, right? A position time graph is a straight line. So out of these four choices given, which is the correct statement about this graph? First one, this graph represents motion with a constant positive acceleration, motion with zero acceleration. Third one, motion with zero velocity. Fourth one, motion with a constant negative velocity. So in this graph, you can see this position time graph is a straight line. What is the relationship between a position time graph and the speed? In a position time graph, the slope, that is equal to velocity. Slope is equal to velocity. So it has a positive slope. As it has a positive slope, motion with zero velocity, this is not correct because it is moving with a velocity. If zero velocity, then slope will be zero. The graph will be like this, a horizontal line. Motion with a constant negative velocity, here slope is equal to velocity, and you can see this graph has a positive slope. Negative slope means the graph will be like this. This line has negative slope, right? This line has positive slope, so it has a positive velocity. So this is also not correct. Then motion with a constant positive acceleration, this is also not correct, because if a motion is an accelerated motion, then its position time graph will be a curve. For an accelerated motion, position time graph will be a curve. If position time graph is a straight line like this, which means acceleration is equal to 0. Why acceleration is 0? Because its velocity is constant. How do you know velocity is constant? Because the slope is equal to velocity and the graph is a straight line. A straight line always has constant slope. A straight line, I will write here, a straight line always has constant slope. So constant slope for a position time graph, which means constant velocity. Constant slope means constant velocity. Constant velocity means zero acceleration. If velocity is constant, acceleration is 0. So this graph represents motion with motion with zero acceleration. So this is correct. Why this is not correct? Here it is given motion with a constant negative velocity. Here actually velocity is positive, not negative. Why velocity is positive? Because slope is positive. Why slope is positive? Because the line is like this, not like this. If the graph is like this, going down like this, so slope is negative. Karim drops 3 balls with different masses from same height. Which ball has the greatest acceleration? So Karim is dropping three different ball, one 3 kilogram ball, another one 2 kilogram ball, and another one 1 kilogram ball. Karim is dropping this three ball. Which one will be falling with the greatest acceleration? That is the question, and they have given four choices as usual: the red ball, the yellow ball, the blue ball. All have the same acceleration. So here three different balls, right? Different masses. If I drop, for example, if I drop this duster and this cap of the marker, if I drop it, both will have same acceleration. Both will reach the ground at same time. Both will reach the ground at same time. Why at the same time? Because they have same acceleration irrespective of mass. You drop a 50 kilogram rock and a 100-gram stone, both will reach the ground at same time. Why? Because they will have same acceleration. All the balls will have same acceleration. What is the value of the acceleration for all the ball? 9.8. 9.81 I will write 9.81 meter per second squared. 9.81 meter per second squared. Whether mass is high, mass is small, no problem. All the ball has same acceleration, 9.81 meter per second squared. So what's the answer? All the ball fall with same acceleration. Okay, don't write yellow ball, don't choose red ball, choose all the ball fall with same acceleration. Mass of a falling object does not depend on the value of the acceleration, and all the ball will reach the ground at same time. The next question is from velocity time graph. So on y-axis velocity and on time axis, on the x-axis time. Always in motion graph, time is always labeled. On the x-axis, Yusuf is learning to ride a bike. I am not writing completely, okay? Lengthy question, so to save time, so I am not writing the question, I will read it. And if you ask for the PDF of this, I will send it. If you need, you can ask. Yusuf is learning to ride a bike. His father pushes with a constant acceleration for 4 seconds. So up to 4 seconds, his father is pushing his bike. So it is moving from 0. Initially it's starting, right? Then it is accelerating, okay, with a constant acceleration. Means as his father is pushing, the speed is increasing. Then after 4 seconds, Yusuf continues at this speed until he completely stopped after 3 seconds. So he is from 4 seconds. Okay. Then Yusuf continues at 6 meter per second for another 5 seconds. Okay, for another 5 seconds. So up to 9 seconds, Yusuf is moving with a speed of 6 meter per second, right? Yusuf is moving with a speed of 6 meter per second at a constant speed. Before slowing down until he completely, means again after 2 means 9 plus 3 is 12, right? So when it is 12 seconds, he stops. So this is the graph given here. And the question is, what is Yusuf displacement in the first 9 seconds? you need to calculate his displacement in the first 9 seconds. So displacement up to here you need to calculate. From here to here you need to calculate this displacement. Okay, if I shade this area, so this you need to calculate this displacement. Velocity time graph, right? How to calculate displacement from velocity time graph? From velocity time graph, displacement that is equal to area under the graph. Area under the graph. If a velocity time graph is given and they ask you to calculate the displacement, what you need to do? You need to calculate area under the graph. What is the area? Is it a triangular area? No. It is a rectangular area? No. It's a trapezium, right? The shape is trapezium. You can do in both, in either way. Like for example, you can divide this into a triangle and a rectangle, and you can calculate area of this triangle and area of this rectangle, and you add both the area, you will get the displacement. As it is a trapezium, okay, trapezium, we will calculate using the area of trapezium equation. For area of a trapezium, area that is equal to half multiplied a plus b multiplied h. Half. What is a and what is b? A and b are parallel sides. A and b are parallel sides of a trapezium. What is trapezium? In a trapezium, two sides will be parallel and other two sides will not be parallel. So it is a trapezium. So here, so this is one side, another side. These two sides are parallel. So we will take this A and this B, or you can take this A and this B, either way. So half multiplied A, what is the value of A? From here to here, 9. 9 plus, what is the value of B? From here to here, that is 9 minus 4. 9 minus 4 is 5, right? 1, 2, 3, 4, 5. Multiplied h. H means height of the trapezium. So what is the height? This is the height of the trapezium from here to that maximum height. What is the value of the height? 6. Half multiplied 9 plus 5. 9 plus 5 is 14, right? 14 multiplied 6. That is equal to how much? Half. Now need to calculate, right? 7 into 6, that is 7 into 6 is 36 in plus 6, 42. So 42 is the answer. Here 42 there. Yes, 42 meter. 42 meter is the answer. 42 meter. So here in this question, you cannot see this, right? 4 choices given. What are the 4 choices? They have given 6 meter, not correct. 42 meter, correct. 30 meter, not correct, right? Why not correct? Because we have already calculated and we got the answer. And the answer is 42 meter and 51 meter, not correct. So 42 meter is the correct answer for this question. The next question is from velocity time graph. So this velocity time graph represents motion of 5 runners in free marathon. Which one of the runner changed his direction during the marathon? Changed his direction during the marathon. So first we will talk about the A, first one. Is that correct? So here you can say this is the velocity axis, y axis, and this is the time axis. So velocity above this origin, that is positive value, positive velocity, and velocity below the origin, negative velocity. So positive velocity means the man is moving towards right side, and negative velocity means the man is moving towards the left side. So in the first one you can see, first one for A, for this one, here velocity is always positive, right? So this is not correct. It is not changing the direction. If it is changing the direction, velocity will change the sign. If velocity is positive, it changes to negative. If velocity is negative, it becomes positive. Then we can say it changes the direction. So here velocity is always positive. For this one, it's not changing the direction. That man is not changing the direction. So that is not correct. Then B. B, you can see velocity is increasing, right? But velocity is always positive. So B is also not correct, because velocity is always positive means it is moving in the right side, towards right side. It's not changing the direction. If the runner is changing the direction, velocity will change the sign. Then C. Velocity, you can see it is decreasing to 0, but it is positive, right? So C is also not correct. Then D. So here you can see initially the velocity is negative, right? Here see, this is the negative section of velocity. So velocity is negative, 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 negative. When it reached here, velocity became 0. After that, what happened? After that, velocity is increasing. After that, velocity is increasing, which means he is changing the direction. So first, for example, we can say first he is moving to the left side with decreasing velocity, means his speed is decreasing. Okay, speed is decreasing. Then what happens? Then he reached here, he stopped for an instant, so velocity becomes 0. Then again he accelerated, he increased his velocity. So this is the correct one. Okay, this velocity time graph represents the runner is changing the direction. Why? Because this section velocity is negative and this section velocity is positive. So D is the correct answer for this question. In this question, okay, in the next question, the motion diagram below shows the motion of 4 buses moving along the x-axis. Which buses have positive acceleration? So positive acceleration means velocity is increasing. Okay, so there are two way of having positive acceleration. First one is moving to the right side with increasing velocity. The bus is moving towards right side and velocity is increasing, then acceleration will be positive. Do you understand? Bus is moving to the right side and the velocity is increasing, so acceleration will be positive. The second way is bus is moving to the left side. Bus is moving to the left side and velocity is decreasing, then also acceleration will be positive. So there are two ways for positive acceleration. Number 1, the bus is moving towards right side and velocity is increasing, so acceleration is positive. Second way, the bus is moving to the left side and velocity is decreasing, so acceleration is positive. So here you can see in this first one, A, bus is moving to the right side and velocity is increasing. How do you know the velocity increasing? That is from the length of the arrow. This arrow represents velocity. So here you can see the length of the arrow is increasing, which means velocity is increasing, and bus is moving to the right side, so acceleration is positive. Acceleration is positive. What is this plus represent? Positive. Okay, should I write positive completely or will you understand that? Okay, so here in C also correct. Bus is moving to the left side and velocity is decreasing. How do you know it is moving to the left side? See the arrowhead, the direction of the arrow, it is to the left. How do you know velocity is decreasing? Because the length of the arrow is decreasing, that is why velocity is decreasing. So bus is moving to the left side and velocity is decreasing, then acceleration is positive. So what is the answer? A and C. A and C represent the acceleration is positive. Then what does B represent? The bus is moving to the right side, velocity is decreasing, so acceleration is negative. Here bus is moving to the left side, velocity is increasing, acceleration is negative. Don't get confused, okay? It's very simple. Just write it down. Acceleration is positive. Two ways, right? Number one, bus is moving to the right side and the velocity is increasing. Number two, bus is moving to the left side and velocity is decreasing. So in those two cases, acceleration is positive. Now we have two more questions. In that, the one is a Saudi football national player Saleh Al Shahri kicked the ball vertically upwards in Qatar World Cup. What is the direction of ball's velocity and acceleration while going up in the air? So for example, the ball is going up or this marker is going up. While going up, velocity is upward, right? If you are going to the right side, what is the direction of your velocity? Right side. If you are going to the left side, what is the direction of your velocity? Left side. If you are going upward, what is the direction of the velocity? Upward. If you are going downward, the direction of velocity is downward. How this type of question a student can select a wrong answer? The direction of velocity will be along the direction of the motion. If the ball is moving up, the direction of velocity is upward. But what is the direction of acceleration? So velocity direction, that will be along the direction of motion, right? Velocity direction, that is equal to direction of motion. So this ball in Qatar World Cup, Saudi player kicked, it's moving upwards, right? So velocity is upward. Velocity is upwards. Okay. What about the acceleration? Acceleration direction means direction of acceleration. Okay, acceleration direction, I will just write like that for you to understand. It means direction of acceleration, that is equal to direction of net force. What is F net? Net force. Okay, direction of net force. So when the ball is moving up, ball is in the air, what is the force acting on the ball? The force acting on the ball is force of gravity. Earth is attracting the ball downward, right? That is called the force of gravity. What's the direction of force of gravity? The direction of force of gravity is downward. The only force acting on the ball is force of gravity. The earth is attracting it downward. So acceleration, the direction of acceleration, that is equal to direction of the net force acting on an object. So when the ball is moving upwards, what is the direction of acceleration? Acceleration will be downward. Okay, acceleration is downward. Okay, so this is how you need to know the direction of velocity and direction of acceleration. What is the direction of velocity? Direction of velocity is direction of motion. In which direction the object is moving, that is the direction of velocity. And what is the direction of acceleration? Direction of acceleration is direction of net force acting on the object. Direction of the greater force. In which direction the greater force, if number of forces are acting on an object, in which direction the greater force is acting, or in which direction the net force is acting, that is the direction of acceleration. So here, what's the answer here? Here velocity upward and acceleration downward. Okay, then last question, that is, the question is, which value of acceleration could be found from the tangent at point P in a graph? So here a graph is given. A graph is given. The graph is a velocity time graph, velocity against time graph, and this graph is a curve. Graph is a curve. So graph is a curve means it's not a straight line, right? Graph is not a straight line. If it is straight line, slope is constant, and slope of velocity time graph is acceleration. If it's straight line, slope is constant, so acceleration is constant. But this graph slope is not constant. Why not constant? Because this graph is not a straight line. It is a curve, which means slope is not constant, which means acceleration is not constant. So at a different point, if you take different point, acceleration will be different. And if you want to calculate the acceleration at a given point, the acceleration at a given point, at a given instant of time, that is called instantaneous acceleration. The acceleration at a given instant of time is called instantaneous acceleration. How to calculate that? Draw a tangent. Draw a tangent. What's the meaning of tangent? Tangent is a line that just touches the point, and that is, this line is parallel at that point. Okay, and you calculate slope of this tangent, so you will get the value of acceleration at this time, at that instant of time. That is called instantaneous acceleration. Means if you calculate the slope of a tangent, you will get instantaneous acceleration. So the question is, which value of acceleration could be found from the tangent at a point P? Free fall acceleration? Not correct, right? Free fall acceleration, the value is 9.81 on the surface of Earth. Instantaneous acceleration, that is correct. The slope of tangent at a given point on a velocity time graph is equal to instantaneous acceleration. Okay, so we have discussed all the 25 questions from term 1 examination, term 1 physics examination, December 2022. Okay, watch again and again, practice all the questions. Thank you for watching this video.